Hello and welcome everybody to our today's Fronius webinar. Good morning, good afternoon from wherever you are joining us today. Today's topic is about the Fronius Tauro, and I want to talk about suitable for every system design. So I want to talk about the options that come with the Tauro on AC and DC side to allow us this suitability for every system design. Yeah, my name is Christoph Schirlinger. I will guide you through this webinar today through this next 30 to 35 minutes. And my colleague Michael Raunig is also here today with me. He is responsible for the chat for your questions. So if you have any questions, actually please use the chat function and send them through. Michael is responding then to you and giving you an answer. And also after the slides I want to present you, we will also take a few minutes time to maybe answer a few of your questions live if you have some. Yeah, I quickly want to show you the topics on the agenda today. So we will start at the lower left here with system design differences. So central versus decentral, where is the difference and what options do we have for the Tauro to handle those differences? So this is actually also our second topic here, flexible on the AC and DC side to be able to set it up in a central and decentral system design. Yeah, in the layout examples, I quickly want to show you some applications, how you can set the Tauro up here. And after that, I quickly want to jump into the Conclusio on those slides, on those topics before. So which Tauro in the end should I then use? So which Tauro option should I use for which system? Yeah, and before we end then the webinar, I quickly want to jump to my browser here. So we will leave the presentation and I want to show you live some helpful tools. Actually, it's two helpful tools for the Tauro especially. The solar configurator for the system design, and we have another very important tool now available on our homepage, the so-called Tauro configurator, which you can then use for the searching for the right article number for the ordering process. So this is what I want to show you then live. Okay, so without further ado, let's jump right into the first topic, the Tauro series, very briefly explained. So I hope you already know we will have two systems, two different systems actually here. We have the Fronius Tauro and the opposite then, the Fronius Tauro Echo. We will actually start with the launch of the Fronius Tauro Echo first. So on the left, right-hand side here, the Fronius Tauro Echo will be launched in a few weeks in Q2, and then it will be followed by the Fronius Tauro. And the differences I quickly want to explain. The Fronius Tauro Echo is available in the direct and pre-combined version. So this is actually in the next slide explained then, because here we talk about different system designs or layouts, so decentral and central. We have the perfect option, the perfect solution here with every product portfolio, so Tauro Echo and Tauro. But what's different between the Fronius Tauro Echo and the Fronius Tauro is the number of MPP trackers. As we can see, for the Tauro Echo, we have one MPP tracker. For the Tauro, we have three. And therefore, we also have a little bit of a difference in the MPP voltage range. So it goes from 580 up to 930 volts DC on the Tauro Echo versus a little bit broader range on the Tauro from 400 to 870 volt DC. Also, the available power classes will be different. For the Tauro Echo, you can choose between 50, 99 and 100 kilowatt devices. The 99 version I have not listed here. It's a specific product for some regions, for some countries, but we will get there also in the Tauro configurator. There you can also choose it. And for the Fronius Tauro with 3 MPP trackers, we will have a 50 kV device. Yeah, also the weight will be a little bit different here, of course. Depending on if you choose a 50, 99 or a 100 kilowatt device, it can range between 72 and 103 kilograms. And for the Fronius Tauro with 3 MPP trackers, it will be 74 kilograms. So we can also see it here in this picture. It's gonna be a big device, a commercial inverter. Also on the weight, we can see here, we are not talking about the usual Fronius inverter sizes. It's really a big device for big systems. Yeah, I want to jump straight into the comparison now between central and decentralized. And I want to show it here on 2 schematics. On the left-hand side, we can see a central system design. So actually, yeah, I quickly want to show you here how it looks like. So we have a number of PV module arrays here, and they are all connected to a decentrally localized DC combiner box. So all the MC4 plugs are connected here. And from DC combiner box, we are then going with a bigger DC cable. This is the yellow golden line we can see here. This is a really big DC cable up to 95 square millimeter. We are then running this line to our centrally localized Tauro products. So they are all located at one place here. And the decentralized systems on the right here, we can see exactly opposite. We don't need any DC combiner boxes. We directly connect the MC4 plugs off the strings to the product itself. And then we are running an AC cable, which is usually a little bit longer than here on the central system. Quickly explained these differences in words again. So the central topology is characterized by all inverters are centrally located at one position. This has, of course, some advantages. For example, we have easy transportation of all the inverters to this one location. And also regarding the service, it's good to have them all located at one place. You can all access the inverters easily, so you don't have to run around the whole plant. The module strings are collected via DC combiner boxes, and after that, usually with a thicker cable diameter, we are running big DC cables to the Tauro device. So this is actually below very good shown, I think, in this schematic. So we need DC combiner boxes in this situation. And for the decentral, this is actually characterized by the inverters all distributed across the PV plant. They are not located at one place, and the module strings are connected directly to the inverter. Yeah, and also therefore we don't need any combiner boxes. So this is actually how the topologies are differentiated, and now the Tauro options for those topologies, central and decentral, how do they look like? This is actually also a visualization tool for you. Let's say you can directly see if you have a Tauro central or a Tauro decentral in front of you. So the Tauro central usually has below on the bottom here, we can see big cable inlets on the DC side. So on the left-hand side here, this would be the DC side of the Tauro from the bottom shown. And on the right-hand side, this is always the AC side of the Tauro. And on the Tauro pre-combined for the central system design, we would have these cable inlets for big DC cables. Up to 95 square millimeters is possible. And inside the Tauro, when you open it, you would see those V-clamps. They are looking like this. And this is actually the reason why we can connect up to 95 square millimeter of DC cable to the device on the DC side. This is because of those big V-clamps. And this big V-clamp is actually the same device or the same component, which is also located at the AC side on the right side here. So behind this cover, we would see also AC clamps that looks like this. And yeah, this big AC clamps also allows us to connect up to 240 square millimeters of AC cable. Yeah, and the opposite, the direct version, looks like this from the bottom. On the DC side, we can clearly see MC4 plugs for the direct connection of the module strings, and also on the AC side, here we would have see a different AC option. So this would be a multi-core option, but nevertheless, it's also the AC side, and behind this cover, we would again see these same big AC clamps, V-clamps, sorry, which allows us to connect up to 240 square millimeter of AC cable. Yeah, and also another differentiation here between pre-combined and direct version would be when we open the front cover and look at the DC area, the DC connection area, we would see string fuses. There is a whole print board inside. For every string that we can connect here, there is also a string fuse, which we can exchange, of course, if there is a malfunction. This would be, of course, not possible for the pre-combined version because we have those big V-clamps inside. Yeah, so this is what the Tauro options then look like from the outside and also from the inside here with the V-clamps for those two different system topologies. And there is also another option for both Tauros, direct and pre-combined, and this option is called AC daisy chaining. This is a very unique way of system design where you can save a lot of money on the cable costs of the AC side. The basic idea is actually to have, like shown in this graphic here, to be able to connect multiple Tauro inverters on the AC side together, and then from the last Tauro product, you then go directly to the main distribution frame instead of having every product cable to the main distribution frame individually. So therefore, you can save a lot of cable costs, of course. And this option actually allows us to combine multiple Tauro devices together. So in a picture, it looks like this. This is the inside of the AC side. So when we look at the device on the bottom, the far right side of the product is then the AC side, as I've mentioned. And this is what we are looking at when we have decided us for a AC daisy chaining option. Usually we would only see one single set of 4 V-clamps inside. That's usually enough. We have one neutral, 3 phases, and at the side of the wall here we would have a connection possibility for the grounding cable. And for the AC daisy chaining, we have double the amount of V-clamps, so 8 in total, and therefore we can come in from one inverter, and from the other set of V-clamps we go then to the next inverter, and so on and so on. And from the last one we go to the main distribution frame. There are, of course, some limits. I quickly want to show you this. So the maximum power we can interconnect to each other is 200 kilowatt. So here in this system, we would have the possibility to connect 4 50 kV devices to each other to a maximum of 200 kV devices, but it would be also possible to interconnect 200 kV devices. For example, this picture down below here on the right. This is actually a real-life application in Greece. So this is actually done with 200 kV devices, and we can clearly see this device on the right here is interconnected to the product on the left, and from there we then go to the main distribution frame. And we are not having to run 2 long AC cables to the main distribution frame, and therefore we are saving on the cable costs. Less AC cables necessary. A big important topic here. But it's not only the saving on the cables, it's also that we need less components, or less components are necessary. For example, if an AC combiner, if an AC disconnector is required in your situation, you don't need 4 AC disconnectors for 4 devices here. You only need one AC disconnector in front of the main distribution frame, with which you would be able to shut down all 4 of them. So this can be also an advantage. Less components. Yeah, and this is an option, of course. You don't have to choose it, but it's optionally integratable and especially for the Tauro possible to choose for both pre-combined and direct versions. Yeah, a short comparative example again to this AC-DC chaining. So I have 3 examples here. And the first one, as we can see here, is an installation without any AC-DC chaining solution and also without an AC combiner. This would actually also be an opportunity to simply use an external AC combiner. It's also not used here, so we have 2 devices. Let's call it 200 kV devices, and we are cabling them individually to our main distribution frame. Yeah, of course, if an AC disconnector is required, we would need 2 of those on every power line here to shut down the devices. The second example here would be to install the system with an AC combiner box. So here we would have an AC combiner box, and the actual profit here would be that we spare a little bit of AC cabling, of course, and we are also sparing 1 AC disconnector at the main distribution frame, but still not as much savings as we would have with AC-DC chaining because it's already integrated. We don't need any AC combiner boxes, which is also not that cheap if we talk about a big system where we would need multiple of those. And again, we only need 1 disconnector at the transformer at the main distribution frame. So all in all, it's a much cheaper way or a much more cost-efficient way to cable here the AC side. And please don't forget, there is the limit of 200 kV that can be interconnected. Okay, so enough about the AC and the DC side options of the Tauro. Now I want to show you some examples, some applications that would be possible for the Tauro. And I want to start with the direct version of the Tauro on decentral layouts. So the first decentral layout here is on a free field. We would be able to see here a 1 megawatt peak installation with 8 Tauro devices, so 800 kVA are connected here to the main distribution, and this would be a possible way to connect them. Every product for each own is connected to the main distribution frame. Of course, this would be a valid solution here, and the advantages would be that there is no additional DC combiner box necessary because the strings are directly connected, and it's an easy planning because it's a standard design. It's pretty much straightforward solution. Just set the product near the module arrays and interconnect the AC side to the main distribution frame. Very easy to plan. However, there is also the option to use the same situation, 1 megawatt peak and 800 kVA, with a different solution. And here we can clearly see we used the AC-DC chaining option. So each 200 kV blocks are interconnected to each other, and in total only 4 AC cables are running to the main distribution frame instead of 8 that we have seen before. So all in all, we would see, of course, a lot of AC cable savings here in this situation, and still we would have some advantages. We don't need additional DC combiner boxes. Of course, we have shorter AC cabling now with a lower cable costs in the end, and also it's less installation effort when you think about the cable laying. So you don't have to run 8 cables the full length. So this would be 100 meters. So you don't have to run 800 meter of cable, but less 400, and of course the interconnection to the 2 Tauro devices. So in total, less installation effort. So let's jump to another situation here on roof. On-roof layout. Again, we are talking here of a Fronius Tauro Echo in the direct version. That's what the D stands for. And also here we talk about the daisy chain option that we have integrated. We can see the direct option is placed decentral on the roof near the modules, and they are directly connected. And then we have done something different this time. Usually we would see one blue line here. That means one AC cable connection to the main distribution frame. But instead we've chosen the daisy chaining option here because we would have here a very long distance, let's say. Let's say from this roof to the main distribution frame, we would have a very, very long distance, and we would be worried to have very high cable losses over this long distance. And therefore, the designer chooses to use the daisy chaining option, but not to interconnect two Tauro devices, but to use the second set of V-clamps to run a second AC cable. So instead of having one 240 square millimeter cable, we would have now two sets of 230 square millimeter. So in total, it's about 480 square millimeter cable on the AC side, which of course means that we are able to run the double amount of distance with the same cable losses. So for example, this would be possible if we have very long distances, and I quickly just wanted to show you it's not the only way to use the daisy chain option here to interconnect two devices. It's also possible to use it like this. Okay, so that's it for the direct version. Now we jump straight to the pre-combined version of the Tauro for the central layout. So also here I want to start with a free field layout. We also know this application from the beginning. We would have here a 2 megawatt peak installation, let's say, and this would be a possible way to interconnect them. I've already explained how this is working. We have DC combiner boxes decentrally localized across the field to collect multiple arrays, and then we run big DC cables to our centrally positioned pre-combined Tauros. So of course we have advantages here. For example, think about a big installation like here, 2 megawatt peak. We would have long distances here, 200 by 150. That's just an example. But think about the cable losses, the power losses we would have if we would run here with a very thin DC cable. That's of course not good. And here with a very big DC cable up to 95 square millimeters, we don't have to be worried about the power losses here in this situation. So that's of course a big advantage. Also a very easy access to all inverters for installation, commissioning, monitoring, and service. So I've also explained this already. This can also be a very big benefit here because they are all centrally localized. Yeah, another example layout here would be an on-roof layout. Again, this is not limited to the direct version, of course. We can also use the pre-combined version in this scenario. As we can see, we have put the DC combiner boxes up on the roof. We collect all the strings here, and then we run down with bigger cables to the pre-combined version, which is actually localized near the main distribution frame. So we don't have any long AC cables usually in this scenario. So this would be, of course, a solution. And another on-roof solution layout would be like this. For example, there are two buildings here, and each one of them has a PV system on the roof. And then we have to run across a street also, maybe underneath. And there is localized our main distribution point. This would be also a very good solution here for the pre-combined version, because the long distances here are no problem regarding power losses for the big DC cables, 95 square millimeters. Yeah, and all in all, of course, it's not that easy to choose, of course. It's also a combination that is possible with the Tauro. We can interconnect both a direct version on the roof here, for example, can be interconnected with a pre-combined version here on another roof. There we can see two pre-combined versions. And also At the other side of the street, we would have a free field installation here where we use a direct version with the AC-DC chaining option to run a very long distance here to the main distribution point. And yeah, as we can see, it's a variety of layouts that we can do here with the Fronius Tauro, pre-combined and direct. So let's jump to a quick conclusio about what we've just heard. Which Tauro option is now best for which system? This is of course not a strict answer here. There are of course different answers which are correct, but there is a way or a guideline, let's say, a rule of thumb, how you can choose if you have to use a pre-combined or a direct. And this is the distance from the PV system to the main distribution frame. So of course, the longer the distance gets, the more likely it is to be safer with a pre-combined version, because the longer the longer the distance gets, which we have to cover, the more beneficial it is to have big DC cables across this distance, because we would have lower power losses because of high voltage and big DC cable diameter. Yeah, and the shorter the distance gets, as we can see here, the shorter the distance gets, the more likely it is to run better with the direct version. Yeah. So in the next slide, I think we can see it very clearly. We recommend to choose a direct version for shorter distances while using pre-combined versions for longer distances. And as we've just seen, also an interconnection of both systems is possible and no problem. So all in all, a conclusio of the AC-DC chaining option. When is it profitable? It's always more profitable at the total cost level. So if the initial costs of the PV system have to be low, it's always good to think about the AC-DC chaining option because it's more profitable. And it's also the best option to save on the AC cable lengths, of course. It's also a very interesting option when the return on investment is most important and lower because we have lower investment costs. So yeah, in every system design, it's very good to think about this option. Of course, it's not suitable for every situation, but I think it's good to have it in mind and always reconsider it. So about the direct variant, Tauro D, this is really ideal for smaller systems. Let's call it below 1 megawatt peak systems and shorter cable distances. And the pre-combined version, Tauro P, is really ideal for larger systems, multi-megawatt, and also for larger cable distances. We've also heard that AC-DC chaining is best if fast return on investment is a very high priority, and also combinations of pre-combined and directs are possible for a maximum design flexibility. So the last sentence here is the Fronius Tauro can be flexibly integrated into any system. So now I want to show you some very helpful tools. On the one hand, we have the solar configurator. I hope you're already familiar with this tool. It's more or less a design tool, a free of charge online tool for your Fronius approved string design. So this is really about having the layout ready. And then there is also the Tauro configurator on the right-hand side here, now available on our homepage. And this is actually for configuring the matching Tauro for your PV systems. So what options do I need for my system? And also to obtain a basis for quotations to the customer and also for ordering the whole device. So, and at this point, I quickly want to quit my presentation here. So, and I hope you can still follow me. I quickly jump to my browser and I've opened here already the solar configurator. So if you want to try it out, simply type in Fronius solar configurator and you should be able to find it. And yeah, in this example here, I've already pre-configured a Fronius Tauro. So at this list, Fronius type of inverter, we can already see the Tauro is already integrated here. We can already find it in the list, and also there we can see the 99 kV version. This is also able to configure here. I've decided now to use a Fronius Tauro 50 in the direct version. So this is the free MPP tracker device, and I've already choose to interconnect the modules like this. And yeah, it's already showing me this would be a perfect solution here. And I don't want to explain it in too much detail, because this is a topic for another webinar. But you can, by simply clicking on the solution here, you will get the string details, voltages, the current will be shown to you, and for each and every MPP tracker. And also at the very bottom, you can then generate a report, which is actually your Fronius approval for this design you have made. So I think this is a really good way to start your project, your system design. Yeah, and the second tool I want to show you is another one. Therefore, I quickly jump to our homepage because I want to show you how you can find this tool. So the first thing we need to do is to choose the correct business unit. We need the solar energy. I click here. And second step is you choose installers and partners here, because the standard is homeowners. So installers and partners. And then we can see products and solutions, and we do a quick click on that. And yeah, there is opening the residential energy solutions, and then second, the commercial. And the second topic here is called Tauro, the robust commercial inverter. I quickly click on that. And now we can see a list of all interesting articles, components, documents, and so on. And if we scroll down, we can see here now a short banner, configure your project inverter online with ease. And if we can click there, configure now, it's opening the Tauro configurator. And this is actually how it looks like. And you can simply click here on, oh, it's in German, sorry, quickly switch to English. And now it's possible for us to click start here. And yeah, now we can simply click through, and at the end, we will get a fixed article number for our ordering process. So I want a decentralized system. I want to choose a 100 kV echo device, for example. 15 amp fuses are fine to me. I want to have a surge protection 1+2 integrated as standard here. And for the AC connection, I choose the single core, for example, not the AC-DC chaining. And yeah, I also want to integrate an AC disconnector, for example. And in the end, we have this configuration here. It tells me the article number, which I can use for the ordering process, and all interesting states all collected here. I can also choose here the quantity. And if I would click next, I come then to the ordering process. So yeah, I think it's a really interesting tool which can help you as wholesaler, as installer, really to to save a lot of time here for the configuration. Okay, I quickly jump back to the last slides I have prepared for you. So quickly turn on my laser pointer again. Okay, last but not least, I want to talk to you about further trainings and education which are possible. You can find them on our homepage. And especially I want to mention that we are offering now a different kind of online experience for you. It's not only the webinars like we have had today, but we also want to offer now to you an online trainings format. This is, of course, because of the COVID situation, but also because the whole digitalization process globally is moving forward very fast. And the online training is more or less a compromised version of our face-to-face training in a digital format, and it's usually taking between 1 and 2 hours, and you can log in and register on our homepage if you're interested. So here we really talk live to you in or we talk to you in a different format with camera equipment to show you really the components and all the details that come with them. Yeah, also I want to make sure that you get the right information. The handout and the recording of this webinar are of course sent out to you, so don't worry, you will be able to look it up once more if you're interested. You're also of course able to share it with your colleagues if you want, the recording or the document. And yeah, next webinars and online trainings can be found on our homepage. I've already mentioned this before. And if you need any information, any contact information, please always make sure to select the right country when going to our homepage, if it's not already pre-selected, because otherwise you may get to the wrong contact. So always choose the right region where you are joining our homepage from, and then you should be able to get the right contacts out of our homepage. Yeah, so actually I'm at the end now of this webinar, but before we close our session, I quickly want to ask my colleague Michael if we had any questions during our session, and if we can answer a few of the questions live.
Yeah, thank you, Christoph, for the very interesting webinar. I hope you guys enjoyed it. And hereby, I want to give you some recommendation. We will send out the recording and, of course, the presentation slides. We will send them to you in the next days on your registered email address. So you will receive these slides and recording of the webinar to your email address automatically that you registered for the webinar. So if you have any more questions about that webinar, about that Fronius topics or about other topics, please feel free to ask us these questions into the chat. So if you have some questions, please feel free to ask us. So we will stay online for a few more minutes and then answer all your questions in the live chat. Okay, so that's it. And I want to hand back to my colleague Christoph for the closing words.
All right, thank you very much to you, Michael. And also thank you very much to you, dear attendees, for joining us today. I hope it was interesting for you as well. Yeah, as Michael already mentioned, if there are questions, don't hesitate. And now, yeah, I think it's safe to say we are at the end of our webinar and I want to close it now. Thank you very much for joining us today. Stay healthy and see you next time. Goodbye.